Friends, welcome to our study. In this video, we are going to solve RS Aggrawal for class 9, chapter number system, exercise 1C. So, the first question is, what are irrational number? How do they differ from rational number? Give example. So, first definition of rational number. So, the number which cannot be expressed as a terminating decimal or cannot be expressed as repeating decimals. Okay, these are known as rational number. Is called as rational numbers. On the other hand, what are irrational number, or what is the difference between rational and irrational number? So the difference is rational number can be terminating, and if not terminating, then it must be repeating decimal. So the rational numbers are terminating, or if not, then it must be repeating decimal, which are terminating or repeating decimals. Okay, these are known as rational number. For example, 0.101001001000 etc. is a irrational number. Okay, irrational number, but 0.1001 is a rational number. Okay, now the second question is, classify the following numbers as a rational or irrational. Give reason to support your answer. Okay, now the first question is root 3 upon 81. This can be written as root 3 upon root 81, which is equals to root 3 upon 9. Now, if we divide any rational number and irrational number, okay, then the answer is always irrational number. So, root 3 is a irrational number and 9 is rational. Here we are dividing irrational number with rational number. So, this is also a irrational number. Okay, irrational number. So, for reason we will write quotient of rational and irrational is irrational. Okay, quotient of rational number and irrational is always irrational. Okay, the second question is under root 361, which is the square root of 19. It means it is a perfect square. So this is rational number. Okay, the third question is root 21. So root 21 is not a perfect square of any number, so it is a irrational number, not a perfect square, so it is irrational. irrational number. Okay. The fourth question is root 1.44, which is a perfect square of 1.2. So this is rational number. The fifth question is 2 upon 3 root 6. Now 2 upon 3 is a product of 2 upon 3 and root 6, which is root 6 is a irrational number, but 2 upon 3 is rational number. So always the product of rational and irrational number is a irrational number. Product of rational number and irrational number is always irrational number. Okay. The sixth question is 4.1276, which is a terminating decimal. So this is a rational number. Terminating decimal. So it is a rational number. Okay. The seventh question is 22 upon 7. Okay. 22 upon 7 is in the form of P upon Q. So it is rational number. The eighth question is 1.232332333. Okay, it means it is non-terminating and non-repeating. Okay, you can see here 1.232332333. Okay, so it is a non-terminating and non-repeating. Non-terminating and non-repeating. So it is irrational number. Okay, irrational number. Now, ninth question is 3.0400400004. Again, this is non-terminating and non-repeating. So it is also irrational number. Okay, irrational number. Now, the 10th question is 2.356565656. Okay, it means 2.356 is repeating again and again. So it is non-terminating but repeating number. So this is a rational number. Non-terminating but repeating decimal. Okay, so it is rational number. Okay, now the next question is 6.834883. It means 834 is repeating again and again. So it is also a non-terminating but repeating decimal. It means it is rational number. Okay, now moving to the next question, question number 3. Let x be a rational number and y be an irrational number. Is x plus y necessarily an irrational number? Okay. So the question is asking, if we sum one rational number and one irrational number, is it necessary that the answer will be a irrational number? So we will check. Let a is equals to 4, which is a rational number. Sorry, let x is equals to 4, which is rational number, and y is equals to root say 7, which is irrational number. Then x plus y is equals to 4 plus root 7, which is a irrational number. Okay, so it is necessarily a irrational number. Hence, if x is rational number and y is irrational number, then x plus y is necessarily an irrational number. Okay. The question number 4 is, let a be a rational number and y be an irrational number. Is a b necessarily an irrational number? So we are saying, for example, let a is equals to again 4, which is rational number, and b is equals to root 7, again irrational number. Okay, irrational number. This is rational number. So a into b is equals to 4 root 7, which is irrational number. Hence, we say that the product of rational and irrational number is always a irrational number. Okay. So, hence we have proved that if a is rational number and b is irrational number, then product of a and b is necessarily an irrational number. Okay. The question number 5 is the product of two irrational is always irrational? Justify your answer with example. No, the product of two irrational number may be a rational number. For example, root 5 is a irrational number. Now, the product of root 5 into root 5 is equals to 5, which is rational number. So we can say that the product of two irrational number is not always an irrational number. Hence, product of two irrational number is not always an irrational number. Okay. Question number 6. Give an example of two irrational number whose difference is an irrational number. Okay. Now, the two irrational numbers with difference an irrational number, like uh, two irrational numbers, say 2 minus under root 3, okay, and 2 plus root 3. So the difference is irrational number. Okay. The second question is, the difference is irrational number. Okay. uh, like for example 2 plus root 3 and 5 plus root 3. This is irrational number and this is again an irrational number, but the difference will be rational number. For example 2 plus root 3 minus 5 plus root 3, which is equals to 2 plus root 3 and minus 5 minus root 3. Root 3 cancels, which is equals to minus 3, which is a rational number. Okay, and in this example 2 plus 2 minus root 3 minus 2 plus root 3 is equals to 2 minus root 3 minus 2 minus root 3. This will become 0 and this will become minus 2 root 3. Okay, which is an example of irrational number. Okay, the third question is the sum is an irrational number. Okay, for example let's say 5 plus root 2 and root 3 minus 5. This is an irrational number. This is also an irrational number. The sum of this rational number will be 5 plus root 2 plus root 3 minus 5, which is equals to root 5. Okay, which is a irrational number. Okay, the sum is a rational number. Now, for example, let's say 3 plus root 2, which is irrational number, and 3 minus root 2, which is a also irrational number. But when we make sum of this 2 plus 3 minus root 2, which is equals to 6, which is a rational number. This is irrational number. Okay, this is rational number. This is irrational number. Okay, the fifth one is the product is irrational number. Let's say one example is root 18, which is irrational number, and root 3, which is also a irrational number. Okay, so now the product of root 18 and root 3 will be root 54. Okay, so this is a irrational number. Okay, this will be root 2 plus root 3. Okay, the sixth question is product is a rational number. Okay, for example let's say this is a irrational number and this is also a irrational number. The product will be root 27 into root 3 is equals to root 81, which is a perfect square of 9. Okay, so this is a rational number. Okay, now the question number 7, examine whether of the following is an rational number or a irrational number. So now check first question, 3 plus root 3. Okay, so check this is a rational number or a irrational number. So for this we will make it a indication that this is a rational number. So if it is a rational number, then we can write it in the form of P upon Q, where P and Q are co-primes. Okay, P and Q are co-primes. Okay. Now root 3 is equals to p upon q, and this will come here with minus 3. Root 3 is equals to p minus 3q. Okay. Now p is also an integer, q is also an integer. Okay. So this whole number is in the form of rational number. Okay. So if this is a rational number, root 3 will be also a rational number. Okay. But this contraindicate that the fact root 3 is a irrational number. Okay. Now we know that root 3 is an irrational. Okay. Since root 3 is an irrational, so this contraindication arises because we have assumed it 3 plus root 3 is an rational number. So this uh, this contraindication has arisen because of our incorrect assumption. Okay. So this contraindication arises due to our false assumption that 3 plus root 3 is a rational number. Hence 3 plus root 3 is an irrational number. Okay. Now the second question is root 7 minus 2. Again we will assume, let's assume root 7 minus 2 is a rational number. Okay. Now we can write it is in the form of p upon q. So root 7 is equals to p upon q plus 2. Root 7 is equals to p plus 2q upon q. Now p is an integer, q is also an integer, 2 is also an integer. So this whole is rational number. Okay. Now if this is rational number, this is also must be a rational number. But this contraindicate contra uh, sorry contradicts that root 7 is irrational. So why this contradicts has been occurred? Due to our false assumption. Okay. This contradiction arises due to our false assumption that root 7 minus 2 is a rational number. Hence root 7 minus 2 is an irrational number. Okay. Now question number third. 5 cube root sorry into 25 cube root which means we can write this as 125 cube root. Okay, so this is equals to 5. Now which is 5 is in form of p upon q, or it is an integer. So 5 into 25 is a rational number. Okay, now the fourth question is root 7 into root 343. We can write this as root 7 into 343, which is equals to 1 0 7 3 21 or 24. Okay, now this is a perfect square of 49, which is in the form of p upon q, or it is an integer. Okay, so root 7 into root 343 is a rational number. Okay, the question number 5th is root 13 upon 117. Okay, we can write this as 1 times and 9 times 1 upon 9, which is equals to 1 upon 3, which is in the form of p upon q. So root 13 upon 117 is a rational number. Okay, now the sixth question is root 8 into root 2, which is equals to 8 into 2, which is equals to 16, which is a perfect square of 4. Okay, and now we know that 4 is a rational number. Why? It is in the form of p upon q, or an integer. Okay, so root 8 into root 2 is rational number. Okay, now this was the last question. Yes, now the question number 8. Insert a rational number and irrational number between 2 and 2.5. Now, for inserting one rational number, if you have learned chapter or exercise 1.a, in which we have already learned the process to make a rational number between two rational numbers. So, if we have to find one rational number, then we have to uh, multiply and divide the same number with 2. Okay, 2 upon 1, this can be written as, okay, into 2 upon 2 equals to 4 upon 2, and 2.5 upon 1 into 2 upon 2, which is 5 upon 2. Okay, now for this we will make a rational number by 4 upon 2 plus 5 upon 2 upon 2, which is equals to 2. 4 plus 5 9 upon 2, which is equals to 9 upon 4, and we can write 9 upon 4 as 4 2 times 8 1 0, 2 times 8 2 0, 4 5 is 20, which is a rational number between 2 and 2.5. Okay, now rational number. Now one irrational number is, we can find this as 2 into 2.5. Sorry, this can be written as, okay, which is equals to root 5. Okay, this is a irrational number. Irrational number. Okay, the next question: how many irrational number lies between root 2 and root 3? So we have already learned that the many numbers can be inserted between two rational number. So the same will be applied to the irrational number. So infinite numbers can be written between root 2 and root 3. Okay, infinite rational number and also irrational number can be lie between root 2 and root 3. Now, find any three irrational number between root 2 and root 3. So, we can write root 2 as 1.414 and root 3 is 1.732. Okay. So, the three irrational number between root 2 and root 3 may be more than 1.414 and less than 1.732. Okay, so the number can be 1.5010100010001. Sorry, one more zero with 1. So these are the non-terminating and non-repeating decimals. Also 1.601001000010001. Okay, and 1.70100100001000001. So these are the three irrational number between root 2 and root 3. Find two rational number and two irrational number between 0.5 and 0.055. 0.55. So for rational number, okay, we have to find n is equals to 2 rational number. For this we must have make the denominator same. So 0.5 can be written as 5 upon 10 and 0.55 can be written as 55 upon 100. For making the denominator same, we will convert this into 50 and 100. This is 50 upon 100. So any number between 50 and 55 is a rational number between 0.5 and 0.55. Okay, so you can write 52 upon 100, okay, which is equals to 0.52. This is a rational number between 0.5 and 0.55. Now for irrational number, irrational number between 0.5 and 0.55 is it may be 0.0 point let's say 51511511115 okay, these are the non terminating and non repeating decimal number. Okay, and other may be 0.535 335 3335 3, 3, 3, 3, 5. Okay, this is also a non-terminating and non-repeating decimal. So this is a irrational number. Okay, irrational number. Now question number 11. Find two rational and two irrational number between 5 upon 7 and 9 upon 11. So for this, the two rational number for first rational number. Okay, we have to make denominator same, and the LCM is equals to 77. Okay, now this will become 55 upon 77, and this will become 9 upon 11 with 63 upon 77. So any number between 55 and 63 are the rational number between these two numbers. So the two rational number, you can say 56 upon 77, okay, and 60 upon 77. These are the two rational number between 5 upon 7 and 9 upon 11. Okay, these are the rational number. For irrational number, we can write 5 upon 7 as 0.714285, which is a repeating. Okay, and 9 upon 11 as 0.8181, or you can say 81 is repeating again and again. So the the two irrational number may be 0.72, 722, 7222, 72222. Okay, this is the non-terminating and non-repeating decimal number, and also another number 0.75, 775, 7775, 7775. Okay, this is also a non-terminating and non-repeating numbers, decimal number. So this is a irrational number. Okay, now find two rational number of the form p upon q between the numbers 0.21211, and 21111. Okay, now this is a, let's say, you can write one rational number between 0.21211, and 0.2020020002000. Okay, the two rational number between these two irrational number may be more than 0.212 and 0. Between less than 0.212 and 202. Okay, so we can say the one number is 0.206 and 0. Let's say it may be 0.204. Okay, these two rational number will lie between these two irrational numbers. So we can write it as 206 upon 1000 and 204 upon 1000, which is equals to 206, 103 upon 500, and 51 upon 250, which is in the form of p upon q, and this is also in the form of p upon q. Okay, find two irrational number between 0.16 and 0.17, Very easy. You can write the two rational number which is irrational number which is greater than 0.16 and 0.17. So it may be 0.161, okay, 0.161, 116, 1116, 11116, okay, and second number 0.169, 669, 6669, okay. These are the non-repeating and non-terminating. So this is a irrational number between the two rational number 0.16 and 0.17. Now this is the true and false question. So the sum of two rational number is rational. Yes, this is true. For example, 4 is a rational number and 5 is also a rational number. The sum is 9, which is also a rational number. Okay. Now the sum of two irrational number is rational number. This is not always true because we have learned some examples of the for this statement in question number 5th. Okay, so this is false. Why? The sum of two irrational number may be rational numbers. Okay, now the product of two rational is always rational. Yes, it is always true. The product of two rational number is always rational number. This is a property of rational number. Okay. The product of two irrational number is irrational. No, this may be a rational. For example, root 5 is a irrational number. So the product of these two irrational number will be a rational number. So this statement is false. Okay. Now the sum of rational number and irrational number is irrational number. Yes, this is always true. Okay, the sum of one rational number and one irrational number is always a irrational number. Okay, this is true. Now the sixth question is the product of non-zero rational number and an irrational number is a rational number. No, this is wrong. Why? The product of rational number and irrational number is a irrational number. Okay, not always rational number. It is irrational number. So this is statement is false. Now every real number is a rational or irrational number. Every real number, uh, this is contraindication, but this statement may not be equal. Okay, so this is false. The real number, every real number is rational or irrational. No, every real number is a group of rational and irrational number. Okay, it may be rational and may be irrational, but not always rational and not always irrational number. Okay, now every number is either rational or irrational. So this is true. The real number is only of two types. It may be rational or irrational. Okay, now pi is irrational and 22 upon 7 is rational. This is true. Why? This is in the form of p upon q, but pi which is equals to 3.14. This when you divide this number, the number will be non-repeating and non-terminating number, which is a irrational number, and this is rational number. Okay, so this statement is also true. I hope you have learned all the questions. If we have any doubt, do comments. Thank you.